Okay, let's take a look at how we can actually graph linear functions. Just to get started, every single function that we look at has a solution set. All this means is that there's a set of coordinates that make that equation true, whether it's linear or nonlinear. This is for every function. If we look at a particular linear function, let me show you what this means. Let's say I gave you y is equal to 5x. Can you think of a set of xy coordinates that would make this true? Think about that for a second. Hopefully you came up with one example, maybe a couple of examples. There's actually an infinite number of examples. That's what we're going to look at in a second. But this particular equation, if I said x was equal to 2, if I plug in 2 down here, 5 times 2, well, that's just 10. Y would equal 10. That's one part of the solution set. That coordinate 2, comma 10 is part of the solution set. And actually, if we graphed y equals 5x, the coordinate 2, 10 would lie on the graph of this function. Okay, that's what we're going to look at a bit later. But that's what it means. A solution set just basically a set of coordinates that makes the equation true. All the inputs of a function are called the domain. Okay, and it's in a set. We call it the set of all the inputs. We'll talk about what that means. But so basically, for our purposes, the domain is really just going to be the x values. So all the possible x values of a function we call the domain. All the possible outputs, aka the y values, are called the range. Okay, now both of these are sets, but that's really what it means. All the x values of a function are the domain. Got to remember that. All the y values are the range. You got to remember that. Okay. Now, just to kind of take a look, there's one more thing that we have when we talk about domain and range. These sets can either be discrete or continuous, and you do need to know what these words mean. Discrete data is basically data that kind of only takes on certain values in a particular interval. They're separate. We can think of them like that. I'll show you what that means in a second. That's really what discrete means. It's really a set of, basically you can look at it as a set of coordinate points that are not connected. Continuous data is, quote unquote connected, and it's every value on a given interval. Okay, so let me show you what that means, but you do need to know what these means. Okay, these are important vocab words, just like domain and range. If you look right here, let me see if I can get this on the page. It looks like it. So here's a discrete domain and range. If I give you this random function that has these coordinate points, if you look at this point right here, the x coordinate is 1. That's part of the domain. The x coordinate of this point looks like 2. There's 2. The x coordinate of that is 3. The x coordinate of this is 4. So our domain would be all the x coordinates, all the inputs. So 1, 2, 3, 4. And let's look at the range, all the y values. It looks like down here we've got a -1. Up here we've got a +1. Up here we've got a +3. This is a +5. That's a 1, by the way. That's where -1, 1, 3, 5 comes in. The range is all the y values. That's what that means. And this is what I meant when I said that for discrete domain and range, they're kind of separate. You see how they're not connected at all? That's what that means. It looks like just a bunch of coordinate points plotted on there. Now for a continuous domain and range, it looks a lot different. This right here, it's got an inequality in there. This looks all kinds of weird, okay? But what it means is that for this particular function, we don't know what it is, but we do know that the domain is every single x value that lies in between -2 and +2. And the range would be every single y value that lies in between -3 and +3. Everything. That's why they're connected. I could pick some random point like right here. That looks like, I don't know, 1.1 comma, 2.4, right? And that would be a solution set. So any point that you pick in here is a solution set for whatever the function may be. Okay? That's what that means. Continuous, discrete. That's really what that is. Now, let's take a look at a couple of examples and see, can we determine if a function that we're given is discrete, if it's continuous. I do want you to know that, but our main purpose is what is the domain? What is the range of a function that we are given? So try this one really quick. Look at what's the domain. I probably should have put numbers on here. What's the domain and what's the range of this function? And if you look, it looks like this one, all the inputs, all the x values are 2, 4, 6, 8. What you want to do is you want to put it inside of, that's a curly brace. So those are proper curly braces. Most of you guys can probably do that. But the domain, it looks like we've got 2. Let me write that in there. We've got a 2, we've got a 4, we've got a 6, and we've got an 8. That's all I see for the input, right? That they give us. Now there's no equation, so there's nothing, we can't go any further. Maybe it's continuous. It could be continuous, but all we know for right now is what they've given us is the inputs are these 4 values. The range, all the y values, all the outputs. What do you see? I see a 6, I see a 10, I see a 14, and an 18 right in there. And that's our range. So the domain is this, the range is that. And from what it looks like right here, although we could come up with an equation for this, if you just had these plotted on a graph, I don't know, let's pretend it was something, like this, that, this would be discrete, okay? This would be a discrete set of points, okay? Discrete domain and discrete range. Now, if you look right here, we'll do the same thing. And actually, I should have put a graph on the last one, but let me go through. Let's plot these points. Okay, so take a second and plot them. If you want to write them down quickly on a sheet of paper, you do want to know how to plot on a coordinate plane. So this is important. Now, let's say we had, looks like right here, -1, -2. We've got 0, -1, 1, 0, and 2, 1. And if you look, this right here, that's discrete. These are just a bunch of different points that are not connected. If I had connected them, okay, boom, that would be continuous, right? But it's not. They're just different points, all separated. That's discrete. Now let's try this one. This one's a bit different, okay? We don't have any points. I didn't give you any points. I gave you an equation though, right? So take a second and see if you can pick some points that would be solution sets for this equation. Pick a set of XY coordinates that make that true. And if you notice, it's kind of, now if you tried it, hopefully you gave it a shot, but there's no one place to start. With this, I could plug in -1 million technically, and I get a Y value back. I'd get -2 million. But I'm going to start with nice numbers. Let's say X was 0. If I plug in X equals 0, 2 times 0, that's 0. Look at that, that's a point. If I plug in 1 for X, 2 times 1, that's 2. I get 1, 2. Nope, that's not 1, 2. 1, 2. If I plug in X is 2, 2 times 2, that's 4. Our output would be 4. And I think I might have picked, let's go backwards on this. Let's say X was -1. If I plug in -1, -1 times 2 is -2. So we're right here, -1, -2. Now the only thing with this is if you look and you said, oh, look, it looks exactly like what Justin said. That's discrete, right? But I could pick any value of X in between here. I could pick X as 0.1. And I would get, Y was 0.2. That'd be, somewhere like right here, somewhere like that. And I could pick all these different values in between these points that I've given you, right? What this is a continuous domain and range. Every single value in between a specific X and Y value, every single value is part of the range, the domain and range. And for this particular one, I'm not asking you what the domain and range is for a reason, but what I will tell you is if you take a guess, try it and see what you get. If you look and I were to ask you, hey, what's the domain and range of Y equals 2X? The domain is all real numbers, or -infinity to +infinity. Some of you may have talked about this already in class. The range is the same thing. Every single number is part of it. I can pick any input. There's no input that's off limits. I could pick 1 million, 1 billion, trillion, 0.1, 0.025 for an input, and I'll get an output out of that, right? So that's what that means for this. Basically, let me generalize it with this. What I will tell you, this is actually important as well. Well, this is all important, but you know what I mean. So all linear functions, I don't know why I capitalized linear. All linear functions have a domain and range of all real numbers. What they'll say sometimes is negative, let me write this out, negative infinity. If you haven't seen this symbol before, you may or may not have -infinity to +infinity. Every number in between we can pick for X and we'll get a Y value back, okay? So all linear functions have a domain and a range of all real numbers. Sometimes they say all reals, sometimes they say -infinity to +infinity. You'll see all three of them and more. Okay, that's what that means though. So if we take a look at the next one, let me screen this a little bit. Try the same thing we did last time. Pick a couple points, see what would make sense, and see if you can get any particular input and see what the output is, and plot it, and then see if is it continuous or is it discrete. So for me, just so I can actually plot it on the graph, I'm going to pick X equals 0. If you notice, that's a trend. If you ever don't know a value for a function, always try X equals 0. That's usually a good place to start. If I plug in 0 for X, I get 3 times 0 minus 5. So I get -5, so we're down here. If I pick X equals 1, 3 times 1 minus 5, that's -2. So 1, -2, and then let's try X equals 2. 3 times 2, that's 6, minus 5, that's 1. So I plug in 2, I get a +1 back. Now again, if you look, this looks exactly like what we were talking about, whether you in the last section where you have to determine if something is a linear function or not. This looks exactly like that form we talked about, y equals mx plus b, where b is just a -5. The plus that's perfectly fine. So this is a linear function, actually. And if you remember what I just said before, see if you can remember without going back, all linear functions have a domain and range of what? All linear functions have a domain of all real numbers and a range of all real numbers. So we actually connect the dots on these ones. And I should have said this in the last example. We put an arrow here going both directions because it goes up infinitely. Like I can't graph infinity, so that's why we put an arrow, because it goes up forever and it goes down forever. So I could put in, like if you imagine putting in 1,000,000, right, for x, we would get a y value back. Imagine putting in 0.001 for x. We would still get a y value back. You would need a calculator for that probably, but that's the main idea for this one. The domain and range are all real numbers, or -infinity to +infinity. And that's really what it means for these ones when we talk about the domain and range, when we talk about how do we graph linear functions. You really, as you start these out, this is what we pretty much do all the time, is when you first start graphing, like we can start with this. Just pick a couple inputs and see what the output is, and then plot those points. And then once you do that, you'll know, oh, wait a minute, this is a linear function. Justin told me I connect them. Always connect the dots on these ones. If I just give you a random set of points and I don't tell you it's a linear function, I don't give you any equation, then you draw the points and you're like, oh, it's discrete. That's cool. But remember, and I'll say this again, just so you hear it, linear functions have continuous domains and ranges. Any point that you pick in the domain and range will give you a value back, or any input that you pick in the domain will give you a value back for the range. Okay, so any input will give you any out. I think I said that wrong. Any input in the domain will give you an output that lies in the range. And for linear functions, again, I can't stress this enough. All linear functions have a domain and range of all real numbers. Any number that you pick, you can plug into a linear function for the input, and you'll get an output back. Okay. So that, in a nutshell, is how we graph linear functions. I kind of went a little further than I wanted to. I want to go more in practice. When I give you the practice problems in the description, if you click on that link, what I'm actually going to do is I'm just going to give you the function, and I want you to graph it. That's my main purpose. Obviously, you need to know what the domain and the range mean. Those are the most important vocab words from this section. Discrete and continuous, you definitely need to know those as well. But my main purpose for this is obviously to make sure you're comfortable graphing linear functions. One of the most tricky things that you do, because once you're comfortable with that, there's a lot of other functions that we're going to be graphing in algebra. Algebra 1, Algebra 2, obviously pre-calc and calculus. So graphing is a huge thing. Okay, we don't just get to use a graphing calculator all the time. Most of you know that there are non-calculator portions of tests, which stink. We don't like it, but it is what it is, right? So you have to know how to do these by hand for the most part. And that's what the practice is all about. And again, the main idea from this section, obviously for the vocab, it's to know that the domain is all the set of all the inputs, or the x values. The range is the set of all the y values, or the outputs, and to know what the difference between discrete and continuous is. Continuous is that value can be anything inside of it. If it's discrete, it can only be a certain value. So think of it as like just the points that are not connected, right? Something like that. But my main goal from this section is obviously the name of it. It's graphing linear functions. Make sure you're comfortable how I got these with graphing. And if you're not, try the practice problems. There'll be at least a few because you do need to practice these. Make sure you obviously go through the questions before you look at the answers. I say that almost every video just so y'all know that's the best way to practice. Don't automatically jump to the answers. Okay. So hopefully this video helped, and we'll see you in the next one.